Hello, ladies and gentlemen. This is Mr. Huff. Let's talk about doing some cost analysis on this building. It is a 12 by 16 foot shed, and that's what we're working on. So we know that we have this little shed. So what you're trying to do is figure out how much you're going to spend on materials. So something we figured out, and this is in previous videos, we figured out that it's going to take, let me get a highlighter here, that it's going to take about 2.5 yards of concrete to make this foundation, and I need 23 pieces of rebar to build the foundation. We're going to bring that in. I also need some 2 by 6 by 12 and 2 by 6 by 16. Our building is 12, wrong one, let's put this in a different color. Our building is 12 by 16. That's the example I'm using, all right? So in my notes, these are the drawings I did to help me figure out the 12 by 8 wall and the 16 by 8 wall to count the number of studs, how many boards I need in the sole plate, and that sort of thing. I also spent some time right here looking at windows and the door to figure out how many partial studs I would have and how many headers I would need. Let's look at some of the calculations. So this is a snapshot of my notebook where I'm figuring out just on the east wall how many studs, how many pieces for a sole plate, how many pieces for the top plate, and I kind of messed up there a little bit. So, but I have a total there, so I know that for this wall, I need 12 2x4s to make it work. And that's just one of the, either the east or west wall in my model. And then my north and south wall is 16 feet. And that's not what I wanted to do. Okay, so 16 feet. So let's look at what I need here. I figured out how many studs I needed, how many I needed for the sole plate, how many I needed for the top plate, how many total 2x4s I was going to need to order. So that was my process on that. If you look here, we are talking about anchors. So I figured out how many anchor bolts I needed on the 12-foot wall and on the 16-foot wall and got my total for the entire building right here. Remember, these are, let's put some numbers down so you can remember. We have to go in from the end, 1 foot from the end, and less than 6 feet between the anchor bolts. So if you're going to maximize it, you want exactly 6 feet between every anchor bolt if you can. That's kind of the goal. So in this case, for this building, I would need 14 overall, 3 for the east, 3 for each wall on the east and west, and 4 for each wall on the north and south. This is where I started thinking about the total for the building. So I figured out how many studs I needed for the total for all the walls and how many I needed for the top plates and the sole plates. So those are some of the numbers I have right there. That's not the right thing. So I have these numbers here. And then I also thought about how many windows my building had and how many doors I had. And I thought about those for a little bit using the drawing I showed you earlier. And then I figured out how many partials I would need. So that's what that is about right there. So I figured out I needed 11 partials to make 3 windows and 1 door. And then we start looking at surface area. So I have found the surface area of the small wall and surface area of the long wall. And then I used 448 for figuring out sheathing and paint and R11, the insulation, and that sort of thing. And then I remembered that I also needed to include gables. So I went over and did some math for my gables. And here that is. So I went through and figured out, starting from my 12-foot wall, the size of this triangle here, using a little bit of Pythagorean theorem and properties of triangles. So this was one of my gables right here, okay? So it's 7 feet on the base, 5.25 on the height, and the hypotenuse is 8.75. All right, let's go back and look. So then I had to go back and redo all of these calculations with the sum of the walls plus the two gables. So that ended up with a total area of 521.5 square feet. And using that, I could go back and recalculate the everything that was 32 square feet in the R11 insulation and how much paint I needed and that sort of thing. It was real terrible on the insulation. I have to get 3 rolls, and I'm only going to use just a very, very, very tiny portion of the 3rd roll. So next, I thought about the rafters. So this is my roof. It's 18 feet long from one end to the other. Remember, it's the long wall, 16 plus 1 foot overhang on each end. And I found that the hypotenuse is 8.75, so that's this length on this side. So that is a little, this is a scale model or scale drawing of my rafter system. Also, I went through and spaced every 2 feet and counted the number of rafters from top to bottom. And let's go, also notice the ends, it's doubled up on each end. It says that in the instructions. So I went in and started looking at how many 2x6x8 boards I needed to do this. So I thought about the ridge, I needed 3. And then I thought about the rafters, and I came up with 28. Okay. And then there's also something called blocking, and it's basically, it's like the ridge, but it's down at the bottom. It's kind of the seal point between the top of the wall and the roof surface, filling in that space where the 2x6 is. If you don't do that, you have a bunch of little holes where the rafters meet the top of the wall. It's basically the same as a ridge, but it's on the lower end, so you need 2 of them. And so that means I would need 5 boards for that blocking. Okay. So then looking at the roof, I look at the roof surface. So it's length times width times 2. We have 315 square feet. I figured out sheathing, felt, shingles, R19 insulation, which has 118.83 square feet per bundle. Okay. Also the fascia, this is a kind of a wide thin board that goes around there in 10-foot sections. So I took the total length for the angles down the ends, the tops of the gables, 35 feet divided by 10. So I need 4 pieces for that. And then the 2 long runs on each side. So that's 36 feet, and I would need 4 boards for that. And then there's also a thing called drip edge, and it's just on the bottom edge underneath the shingles of the long sides of your roof. And so that's 2 times 18, which gives me 36 feet. So I need 4 pieces of that drip edge. All right. So a useful thing to think about is cost per square foot. When I did this calculation, I ended up with about $4,700, and this is for a 12 by 16 shed. So the dollars per square foot is interesting to us, and my calculation was $24.47, which means if you do your calculations and you end up with about $25 per square foot, plus or minus some number, I don't know, probably like 20% or so, you're probably in the ballpark with your estimation. If you're finding that you're $40 a square foot or $60 a square foot or $3 a square foot, something is wrong. So you'll need to keep that in mind as well. So that's just a real quick overview of how to do these this calculation for everything. All right. Thanks for watching.